Hey Dalton, this is Mr. McCann here at West Union. I heard you're going to be joining my college algebra and trigonometry course for the year. I hope you're doing well, and I look forward to having you in class. I know you've missed a couple of lectures so far, and maybe you're going to miss a few more before you're able to attend, so I'm going to go ahead and take the time to create online videos for each of the lectures, and then I'll also send you a copy of the guided notes that go along with the video. I'm going to send you a copy of this printed out document, and then I will also send you a copy of the assignment that goes along with it. And then once you get back, we'll worry about getting you caught up in terms of exams and all that, but for right now I think that's the best way to handle the situation. So this is our first section of notes. Right now we're talking about just reviewing the different types of equations that we're going to see in college algebra and going over how to solve some of them. So first off, just to define an equation, the definition of an equation is two expressions where one or both contain variables that are set equal to each other. So, and here I have 6 examples of different types of equations, and as you notice in this first example, I have it defined as a linear equation because the only variable that's showing up is the variable x. Now in the second equation, we have the variable x showing up, and then we also have an x being raised to the second power, known as an x squared. The presence of the x squared makes this a quadratic equation. Now in the third example over here, x squared minus 4 equals 2, we call this a rational equation because of the presence of the fraction bar. The rational numbers are any number that can be written as a fraction. Therefore, a rational equation is any equation that has the presence of a fraction. Now, the radical equations are any equation that involves a radical, whether that be a square root, a cubed root, a fourth root, any kind of root or radical, where the variable is contained inside of that radical. The first 4 here, linear, quadratic, rational or fraction, and radical, will be the 4 types that we primarily go over and review in this unit, but we will also be learning about exponential, which is when we have the variable being the power or the exponent in the equation, and we're also going to go over how to solve and deal with logarithmic equations and the applications of logarithms, and that's when we have the presence of a logarithm contained inside of an equation. So that's the different types of equations that we're going to cover this year. As I said before, this review is just going to go over the 4, linear, quadratic, rational, and radical, as a way to get you prepared for what's expected in this class. So, next definition, solution. A solution is the numerical value or values that make an equation true. If we have multiple solutions, we call that a solution set. So, looking at this problem, x plus 5 equals 9, the solution is going to be the number that we add to 5 to get 9. Now, we know the number that we add to 5 to get 9 is 4. So, therefore, 4 is the solution to this equation. Now, in this next one, a number squared, take away 9, is equal to 0. Well, a number squared, if we take away 9 to get 0, this quantity here, x squared minus 9, would have to be, or this quantity, x squared, would have to be 9, because 9 minus 9 makes 0, and there's 2 values such that we get 9. Negative 3 squared gives us 9, and positive 3 squared gives us 9. So in this case, x could be 3, or it could be negative 3. And when we write our answers like that, we use what's called a set bracket. This bracket here is called a set bracket, and this is the definition of a solution set. When we have multiple solutions, we write them out as a set. X could equal 3 or negative 3. Alright, and now I just want to use the remainder of the video to go over some examples of specifically linear equations, or equations that end up becoming a linear equation. So the first example we're going to do is solving the simple two-step equation 3x minus 5 is equal to 14. Now when we solve this equation, it's just a two-step equation. We're trying to isolate x. So we would add 5 to both sides, and we get 3x could equal 19. And then 3 is attached to x through the multiplication, so we're going to use division, and we get that x is equal to 19 over 3. Now 19 over 3 as a decimal is 6.33 repeating. As a mixed number, it's 6 1/3. It does not reduce, so for this class we will leave the answer as 19 over 3. That's the standard way to answer questions in a college algebra level course. We want to leave it as an improper fraction in reduced form. We want to avoid using decimals unless the problem is asking for the answer in decimals, and we want to avoid using mixed numbers for reasons that will be discussed later on. Now, a second example is the quantity 1/2 times the quantity x plus 5 minus 4 equal to 1/3 the quantity 2x minus 1. Now in solving this one, we have to first use the distributive property. So we're going to distribute the 1/2 to both of these, and 1/2 times x just makes 1/2 x. And then 1/2 times 5, well this is technically 5 over 1, and when you multiply fractions you just multiply straight across. So 1 times 5 is 5, and 2 times 1 is 2. So 1/2 times 5 is just 5/2. Now since our parentheses stops there, we would just bring the minus 4 down. And then on the right side of the equation, we're going to distribute the 1/3 in. 1/3 times 2 is 2/3. So 1/3 times 2x is 2/3 x. And then 1/3 times negative 1 is negative 1/3. Now, looking at this, we have the presence of fractions. So if we were to solve this, we would have to move one of the x's over, which would involve subtracting fractions, which requires us to get a common denominator. We would then have to combine all the numerical values to get a common denominator, and we have to divide by a fraction. So to avoid fractions, there's a trick that we can apply. To avoid fractions, multiply by the common denominator. And if we look here, the denominators are 2 and 3, and the common denominator of 2 and 3 is 6. So we're going to multiply everything in here by 6. And then we're going to just do the multiplication with fractions. 6 times 1/2 is 6/2. 6 times 5/2, well, that's 6 times 5 is 30 over 2. Because once again, remember, this is 6 over 1. We multiply straight across. 6 times negative 4 is negative 24. 6 times 2/3 is 12/3, and 6 times negative 1/3 is negative 6/3. Now you might say, well, we still have fractions. However, if you look at each of the fractions, they all reduce. For example, 6 over 2 reduces to 3x, 30 over 2 reduces to 15, the minus 24 gets brought down, 12 over 3x will reduce to 4x, and 6 over 3 reduces to 2. So multiplying everything by the common denominator eliminates the presence of fractions. Hence, we're able to avoid using fractions. And then solving this, we get 3x, 15 minus 24 is negative 9. And then we solve this from here. So we would add the 2 over, and we would minus the 3x over, leaving us with negative 7 is equal to x. Alright, so that's an example of a type of linear equation that we're going to deal with in this classroom, and it's important to draw from this trick. Anytime we have an equation where fractions are involved, we can apply this trick of multiplying by the common denominator to eliminate the fraction. So that's a common trick that we use in a college algebra level course. Alright, now going over a next example. Sometimes we have problems where we have binomials being multiplied by other binomials. So for example, 2y plus 1 times y minus 1 is equal to y plus 5 times 2y minus 5. Now in solving this, the first thing we're going to do is we're going to FOIL each of these quantities out. So we're going to do 2y times y to get 2y squared. We're going to do 2y times negative 1 to get negative 2y. 1 times y is y. 1 times negative 1 is negative 1. And then we're going to do the same process for the other side. Y times 2y is 2y squared. Y times negative 5 is negative 5y. 5 times 2y is 10y. And 5 times negative 5 is negative 25. Combining like terms, we get 2y squared. Negative 2y and y makes negative y. On the other side, we have 2y squared. Negative 5y and 10y makes 5y. And then we realize these problems have y squareds in them, which makes it appear like a quadratic equation. However, if we subtract the two y squareds to get them together, we'll notice that the two y squareds will cancel on both sides of the equation, leaving us with just the variable y, the definition of a linear equation. So then we finish solving like we would any other linear equation. We add the y over to get the variables together. We add the 25 over to get it away from the variables. And we get that 24 is equal to 6y. Dividing by 6 gives us that the solution for this equation is y equals 4. Alright, and then the last type of equation that we're going to complete is a rational equation that's going to end up being solved identical to a linear equation. So, taking a look at this example, 3 over x minus 2 is equal to 1 over x minus 1 plus 7 over x minus 1 times x minus 2. Now with rational equations we have to be very cautious because in a fraction, we cannot have a division by 0, meaning the denominator x minus 2 cannot equal 0 because we cannot divide by 0. So x minus 2 is not allowed to equal 0, and if we add the 2 over, we find out that x is not allowed to equal 2. Now in this second fraction, x minus 1, it's not allowed to equal 0 either. So we add the 1 over, and we get that x cannot equal 1. And then we see both of these appear in the next fraction. So then for the next fraction, x cannot equal 1 or 2, which we've already said that. So what that's meaning is when we solve this equation, we can get any answer besides the answers 2 and 1. If the only answer we get is either 2 or 1, we say that this problem has no solution. So, but this problem is done identical to this second example we did. We have the presence of fractions. When you have the presence of fractions, you multiply everything by the common denominator. Looking down here, the common denominator is going to be x minus 2 and x minus 1. This has a denominator of x minus 2. The second fraction has a denominator of x minus 1. The third denominator has x minus 1 and x minus 2. Therefore, what they have in common is those two quantities. So then we're just going to multiply everything by that. So then that gives us 3 times x minus 2 times x minus 1. And then it's over x minus 2. And looking here, we can see that there's an x minus 2 on the top and bottom of a fraction. So these will cancel, leaving you with just 3 times x minus 1. Then we're going to multiply by 1 by x minus 2 and x minus 1. And then that's all going to be over the quantity x minus 1. And then the same thing occurs. We'll see that the x minus 1's will cancel, leaving us with just 1 times x minus 2. And then lastly, we're going to multiply 7 by x minus 2 and x minus 1. And then that'll be all over the quantity x minus 1, x minus 2. And we'll see that both quantities cancel out, leaving us with just plus 7. So working this out from here, now we have just a regular linear equation. We no longer have the presence of fractions. So we just distribute, and we get 3x minus 3 is equal to x minus 2 plus 7. That's 3x minus 3 is equal to x plus 5. We're going to minus the 2 over, minus the x over, which then makes 2x. We're going to add the 3 over, which makes 8. Dividing by 2 gives us x is equal to 4. Now the only thing that x was not allowed to equal was it could not equal 2 or 1. 4 is neither 2 nor 1, therefore 4 is our answer. If it would have been 2 or 1, once again we would say that this problem has no solution. Dalton, that's going to finish up the first lecture for college algebra. I hope I didn't, if I went too fast, rewind the videos, rewatch. If you have questions, email me. My email is aaron.mccann@ovsd.us. Feel free to email me with any questions you might have. If there's any of this material that you do not look familiar with, you look at that and you say, I've not learned that before, don't worry about it. We'll get it figured out when you get back. This is just getting you used to, here's the types of problems you need to be able to solve. And if you're not comfortable solving these types of problems, we'll figure it out once we meet in person. But I've got an assignment sheet that I will send you to go along with this video. And I'll have the guided notes sent to you, and then I'll also have a printout of all the homework problems. I'm going to go ahead now and write the homework problems out on the next page. That way you don't have to worry about looking for them. Alright, Dalton, you should have a printout of these problems are on it. There's problems 1 through, I have 18 problems total, but these are the first 3 problems. From this video, you should be able to solve these 3 problems, no more. So try to get these 3 problems completed. Let me know if you have any trouble with them. And I hope you get to feeling better. I look forward to seeing you sometime next week. I will be posting another video, hopefully shortly. I will email you when the other video is complete. Have a good night.